UAP Society Research Proposal. Participate like we did with SETI. My proposal would be to use an inexpensive software-defined radio dongle, RTL SDR, to access and download weather satellite images and look for possible UAP objects entering our atmosphere. You may concentrate on satellite images from UAP hotspots like around Groom Lake and Area 51 in Nevada, and weather satellite images over military bases, especially nuclear sites. And of course, track satellites that send images near the famous hotspots, like where Commander Dave Fravor and his wingman Alex Dietrich tracked the Tic Tac in 2004, near Catalina Island and San Diego in Southern California. Or focus your research off the coast of Virginia, often a UAP hotspot where F-18 fighter pilot Lieutenant Ryan Graves reported a cube-shaped UFO in a transparent sphere. In his testimony to Congress on July 26, 2023, he stated that fighter pilots were seeing UAPs on a daily basis in their flight training areas. It was shocking to hear it was a common occurrence for many pilots. I would also concentrate on the Great Lakes in Michigan, over southern Canada and Alaska, where UAPs were shot down by our military jets last year. They say they were balloons, but no images were ever released. So let's discover the facts for ourselves. If these crafts are coming in from space, then it makes sense that some could appear in close-up weather satellite images. This idea may attract thousands of participants, like what SETI did in the late 1980s, and I was part of that. With thousands of volunteers downloading and searching images daily, we might just find a number of credible hits as the UAPs enter or leave our atmosphere. And it's very inexpensive to participate, especially if you're a computer hobbyist. All you need is the RTL SDR module and an antenna. Many satellites like NOAA are not encrypted and are transmitting images 24 hours a day, 7 days a week in real time that anyone can receive. More details. Anyone with a personal computer and an inexpensive RTL SDR module, software-defined radio, or dongle can participate in monitoring weather satellite photos. The module plugs into your USB port and works with the SDR++ or SDR Sharp open source software, converting your laptop or desktop, Apple or PC, into a broadband amateur radio receiver that covers 100 kHz through 1.75 GHz. Some of the satellite transmissions, like NOAA, are easy to find on 137 to 138 MHz. You will need an antenna to get this device to work, and you could even get by using just a long wire connected to its antenna input. But to be specific, the exact antenna length for 137 MHz is 20.4 inches. The RTL dongle is inexpensive at around $29.95 to $34.95. Yes, just $29.95. You can purchase this through Amazon or other sources, and even through AliExpress for a few bucks less. I spent $43.95 for a kit that included 2 different telescoping antennas, an antenna mount, and a cable to connect to the dongle. And you may have great success catching the NOAA transmissions just with the dipole and the telescoping antennas. RTL-SDR.com is another good source for the dongle, related hardware like antennas, plus software downloads and articles on the topic. It did take a little time to install the SDR Sharp software because I had a problem installing the driver into my laptop, but I eventually found a version that had a built-in driver and it worked like a charm. You may also want to run your RTL SDR dongle in Linux using Dragon OS. Now for the meat of my method. Lots of weather satellites that transmit images are orbiting the Earth, many from the U.S. and even some from Russia that you can access. As I mentioned earlier, many satellite transmissions are easy to find from 137 MHz to 138 MHz and with just a telescoping antenna. The satellites cover different regions at different times, and the times and location of these satellites with their radio frequencies are referenced on the internet. One valuable site with satellite data is n2yo.com, with tons of frequency and location data covering lots of satellites. You'll find that NOAA 15 broadcasts around 137.2 megahertz, but you may need to go outdoors with your equipment to pick up the signals. The project that covers this setup is from SaveItForParts.com, also on YouTube, called How to Get Live Satellite Images Directly from Space. You'll pick up the digital signals with the dongle, record it, and then use a free add-on app like WXTIMG to convert the audio data transmissions to images. Depending on the frequency and location of the satellite, you may require a small satellite dish antenna to capture those signals, similar to the Dish Network or DirecTV antennas. You can even get by with a small telescopic antenna if you go outside to pick up the signal. Alternatively, you can build your own dish for a few dollars if you can find one surplus or used, or for one discarded on trash pickup day. A similar project I found is on Instructables.com called Homemade Satellite TV Antenna. In this case, you won't use it to watch TV, you'll just use the antenna to pick up the digital images. Another video from Instructables covers the RTL SDR I'm using. It's entitled Receiving Images from Passing Weather Satellites Using a Cheap SDR. And they show the images. And finally, I found a YouTube video that steps you through locating and decoding the NOAA images entitled How to Decode and Understand NOAA APT Satellite Reception. The channel is dereksgc. It includes all details required to successfully decode the transmission from a number of NOAA satellites. That's my idea and proposal. I'm Howard from Crazy Tech Cyber Times LLC. Please subscribe.